Hi guys, second lesson of the week, last lesson of the week. As you saw, if you looked at the agenda, there's only 2 lessons this week, and then we do a practice test and a test. Chapter 3 is really short, so there's no need for a bunch of lessons and then quizzes and stuff. We're going straight to a test. Now, this test will be worth less points because it is such a shorter chapter. So, yes, it is coming up soon, but there's not a huge amount of stuff that you need to learn for it. It's going to be a shorter test. All right, this last topic, we're finally into 3.2, and this time it's systems of linear inequalities. So systems of equations where you graph 2 lines like y equals 3x plus 2, and then maybe y equals 1 half, oops, that didn't work, 1 half x minus 6. And then you find the point where they cross, and then that's your solution. Okay, I picked a random one, it gave me decimals, whatever. But now we have inequalities. So instead of equal signs, there's going to be greater than or less than. Here. Greater than, less than, greater than or equal to, less than or equal to. We did these before, but not 2 at a time. So if you just have one, and let's say there's a greater than, there was the dotted line in shading, or maybe it was a greater than or equal to, and then it's a solid line in shading. So what we're going to have is 2 lines at the same time, but both of them shaded. So we're going to be graphing 2 at once. We are going to be using Desmos. I'm going to talk a little bit about how you would do it without Desmos. You need to pay attention to whether you're having dotted or solid lines, and you have to pay attention to the shading because it is going to get a little more complicated. All right, let's go straight to examples. Not a big lecture that I have to do. All right, so these appear to be in standard form. Doesn't matter, Desmos can handle it. 4x minus y greater than or equal to negative 1. So what does that look like? I can zoom in a little bit. And 0, 1 is an intercept. Oops. Is there another couple of points that I could plot that might be helpful? Negative 1, negative 3. Connect the dots with a solid line and then shade down below. So it looks like this, right? Now let's do the second one. X minus y is greater than 2. So now we have this purple line here. Let me change colors. I'll switch to red. So there's the intercept. They seem to cross each other right there. There's another key point up there. It's a dotted line. And this one is shaded like this. Now, what does this all mean? All right, I'm actually going to delete the shading for just a minute. I want to talk about something. If you just focus on the lines, we get 4 regions created. There's a region up here, 4 areas maybe. There's one, this narrow shape here. There's an area over here, and then there's one down there. And all of those regions, all of those areas contain points. Here's a point, there's a point, there's a point, there's a point. Lots of points all over the place. Some of those points satisfy one of the inequalities. Some of those points satisfy the other inequality. And some of the points satisfy both inequalities at the same time. And then some points don't satisfy any inequality. For example, if I pick this point right here, negative 2, 2. If I plug it into this first equation, I get negative 8 minus 2, which is negative 10. Is negative 10 greater than or equal to negative 1? No. If I plug it into the second equation, I get negative 2 plus 2, which is 0. Is 0 greater than 2? No. So this point right here and this whole area that it's in doesn't work, doesn't contain any points that'll satisfy or work for either of those inequalities. So what we're looking for is the region that satisfies both inequalities. So what I shaded first in blue satisfies the first inequality, which was here, this blue one. The second one, which I did in red, satisfies this inequality. The points that satisfy both inequalities is the area where the two shades overlap each other. So it's the one region that is shaded twice. On Desmos, it's the darker region. So what does that mean? So I've shaded and colored this problem like a few different times. Here's what it means. You're going to graph this on Desmos. You're going to do the solid line solid, the dotted line dotted, but you're only going to shade the area where the two shades on Desmos overlap each other. And that is the answer we're looking for. All right, let me scroll down and check number 2, just to make sure I didn't do it wrong. That would be awful. There it is. So the dotted line is dotted, the solid line is solid, and only that one little region or area is what's shaded in. All right, with repeated examples, you should get this. Hopefully it'll go pretty well. Let's do this one. So we have x is greater than or equal to 3. So this should be a vertical line. Remember, if there's an x and no y, you get a vertical line, and it's shaded on the right, which is the greater than side. So that makes sense. The second line is 2x plus 3y greater than 9, right there. So, okay, what do I have? Let me just pick a color. I'm just going to stick with one color. I've got a vertical line here, which is solid. I've got a slanted line here, which is dotted. And can you tell what area is shaded twice on the Desmos screen? You should say the upper right. So I'm going to shade in my upper right. And that's what the answer to number 4 should look like. And there it is, upper right, shaded in, solid line, dotted line. So that's what I'm going to be looking for. I want you to do this on Desmos and get good at transferring the drawing over to paper or the screen over here. All right, a few repeated examples. There's some that might be a little trickier than others, so do follow along. X plus 2y is less than negative 6. You know what, I'm going to go ahead and graph that. So 0, negative 3. Negative 6, 0 is over there, sort of. A dotted line like that. I'm not going to shade it yet. Wait till I get the other one in there. X plus 2y greater than 4. So that gives me a dotted line up here. Now, I'm only supposed to shade the area where the two shades overlap each other, where they both touch. Well, these are parallel lines. They're never going to intersect. And one's shaded above, one's shaded below. That means there is no area that gets shaded. This graph, number 6, is literally just that. It's like there's no solution. No shading, no solution. So that was kind of a special case. Let's do number 8. Clear these out. Now this one's in y equals mx plus b form. So here, I'm going to do this like I was in school. Positive 1 is the intercept. The slope is 2, which means up 2 over 1. There is an equal sign. That means I'm going to do a solid line. We covered that already. And when it comes to shading, with a greater than, you shade above the graph up here. I'm going to be erasing that in a minute. The next one, negative 2 is the intercept. The slope is 1/2, up 1 over 2. This is also a solid line. And with a less than, you shade below the graph. So we got one above and one below. Where do they overlap or intersect each other? And I think you can see down here is where they overlap. So I have two solid lines, and that little narrow sliver in the bottom left corner is what gets shaded in. See if number 8 is right. And there it is. So the old school way is really easy to do when it's in y equals mx plus b form. When it's in standard form, it's so much easier to do on Desmos. Of course, you can do number 8 on Desmos. I'm not saying you can't. I'll go ahead and do it. You can see it just takes a few seconds, unless you're trying to talk on a microphone while you're doing it, because then you move slower. But there it is, the same, more or less the same exact picture. It's a little more like that, but yeah, same idea. And only where they overlap is where you shade. All right, let's do number 10. Excuse me. So number 10 looks like I'm going to have a solid line and a dotted line. Y is greater than or equal to negative x minus 1. So that is here and here, solid line through there. And I'm not going to shade it yet. The second equation, y is greater than negative 4x plus 2. So it goes through right there, right here, intersects right about there. Oh, I'm doing a horrible job at drawing this. All right, we'll call that good enough. Here, pretend like that point doesn't really exist. Good enough. Now, where are they overlapped? Is it down here, down here, or up there? Lower left, lower right, upper right. If you look on the screen, the darkest area is up here, so that's what you want to shade in. Let's check number 10. And there it is. Looks perfect. Looks just like the Desmos screen. Did I do solid and dotted? I didn't, did I? Nope. Okay, I got this one wrong. I would lose points on this. I'm just failing all over. That was supposed to be a dotted line. Okay. Well, good enough now. Number 12. Delete these and do 12. Y is greater than x plus 1. And y is greater than x plus 2. Now, these are going to be parallel lines. They have the same slope. So, let me zoom in a little bit if I can. This has intercepts at negative 1, 0, 0, negative 1. It's dotted lines like this. And that's shaded above, but the other one has intercepts here, and it's dotted line shaded above. So, do I want to shade up here? Do I want to shade in between them? Or do I shade down there? Which is right? Well, clearly it's not down here. There's no shading at all. One thing you can do if it helps is change the color. So there, change that to blue and red and turn them off and on, and you can see where do they both get shaded, and that's up here. So this is the only part that gets shaded. In between the graph and here is not shaded because they don't overlap there. So let's check number 12, and there you see just that upper region up here is what gets shaded, not in between. All right, let's do 14, and we are done. This one's back to being in standard position, standard form. 5x plus 2y less than 6. So let me go ahead and graph this. 0, 6, so up here. And wow, 1.20. So kind of a dotted line like this. My dotted line is pretty pathetic, but we'll call it good enough. Not going to shade it right now. Next we have 5x plus 2y. Oops. 2y is greater than or equal to negative 2. And so now we have a solid line. Its intercepts are at 0, negative 1, and negative 0.40. So kind of like that. It's just ever so slightly at a different angle. Where do they meet? 2.8, -8. Oh, so they meet way down off the graph. So it's like way down here somewhere that they would eventually cross each other, for what it's worth. Oops, didn't mean to hit that. So where are they shaded? Where does it overlap? You see the sliver sort of in between them, right in here, is the darkest on the screen of Desmos. You got the red on one side, the gray on the other, and so where they overlap is a bit of a dark red. So yeah, that's a hard one to graph in a way, because my graph only goes down to -5 up to +5, but all the interesting points are like 6, and way down here is at -8. So it's a little bit of a trickier thing to sketch, but still not impossible. Well, that looks like parallel lines. Did I type something in wrong? Oh, I did. Oh, what a loser. You're probably screaming at your iPad right now. That was supposed to be a 2y. Well, for crying out loud, look at that. We'll pretend like Haskell doesn't make mistakes, and here we go. Start over. So, okay, that solid line I guess I had right. So kind of like this-ish. Yeah, I just drew that dot in a bad spot. And then the other one, the dotted line, 0, 3. Good grief. 1.2, maybe somewhere like this. So we're supposed to have a bit of a parallel line. Still doesn't look that good, does it? I probably screwed up my angle. Oh, I'm struggling here. Have pity on me. All right, so this is a dotted line, kind of like that. And still, it is shaded in between them. All right, my drawing kind of stinks. If you get a stinky drawing once in a while, you can still give yourself credit for it, as long as you feel like you did it right. Just a little bit sloppy like me. Totally cool. Give yourself credit. And there it is. So yes, I typed it into Desmos wrong. My picture was a little bit off, but there you go. Okay, enough of this foolishness. You try these problems, odds on your own. Use Desmos. Sketch over here to the best of your ability. Check your answers, and then just give me a holler if you have difficulty. Either send me a message through the comments or send me an email, and I'll do my best to help you. Otherwise, I will